Next problem we're going to do is the exact same type of elastic collision problem. So let's go over this. So we've got a ball, a 3 kilogram ball traveling at 5 meters per second, strikes a 4 kilogram ball traveling at 2 meters per second. The collision is elastic. Boom. So if the 3 kilogram ball is traveling at 3 meters per second after collision, find the final velocity of the ball. Alright. I think the easiest way to start something like this is to get your M1, so your before and your after values. So we'll have M1 and V1 and then M2 and then V2. And then over here we'll do the same thing because none of these objects disappear. M1, V1, then we've got M2 and V2. Cool. So the first object, let's call it the 3 kilogram ball. So my first mass is going to be 3 kilograms, traveling at 5 meters per second. So it's going 5 meters per second. Strikes a 4 kilogram ball traveling at 2 meters per second. So our second object down here is going to be a 4 kilogram ball, and that's going at 2 meters per second. Cool. Collision is elastic. They bounce apart. If the 3 kilogram ball is traveling at 3 meters per second after the collision, find the final velocity of the other ball. So we know the 3 kilogram ball after the collision is traveling at 3 meters per second. So I'm going to write for M1, this did not lose any weight, it's the exact same mass, but it's going 3 meters per second afterwards. The 4 kilogram ball obviously is the same mass too, but we don't know how fast it's going. That's what we're trying to find out. Alright, so let's put our equation down and get started with this. So we've got M1 V1 plus M2 V2 equals M1 V1, so now this is afterwards, plus M2 V2. Alright, before, after. Before, we'll plug in our values. So we've got M1 is 3 kilograms, okay, times 5 meters per second. That was my V1. And then M2 V2, my M1 was 4 kilograms and 2 meters per second was the velocity. So 4 kilograms times 2 meters per second equals. So afterwards, my mass of my first object is still 3 kilograms, and it's going 3 meters per second now. So my mass will be 3 kilograms, and it's going 3 meters per second. Plus, my mass of my second object I know is 4 kilograms, but I don't know its velocity. So this mass will be 4 kilograms, and then I'm just going to write V2 there, times V2. Alright, let's simplify. 3 times 5 gives me 15, and that's going to be 15 kilogram meters per second, plus 4 times 2 is going to give me 8. It's going to be 8 kilogram meters per second, equals 3 times 3 is going to give me 9, and that'll be 9 kilogram meters per second. Okay, and then last of all, I've still got my 4 kilograms times V2, and I'm actually going to keep that in parentheses, since we've still got this 9 kilogram meters per second over there. Okay, so we can add this stuff. 15 plus 8 will give me 23 kilogram meters per second, still equals 9 kilogram meters per second, plus, and then I've got 4 kilograms times V2. Alright, so easy way to get rid of this 9 over here, since it's added to this, is we subtract it. So minus 9 kilogram meters per second minus 9 kilogram meters per second. The units are the same, so we can do this. The 9's over here cancel out. Goodbye. And over here we've got 23 minus 9, which is going to give me 14. So I'll have 14 kilogram meters per second over here equals, and on the other side, the only thing that's left is this 4 kilograms and the V2. So I've got 4 kilograms times V2. All right, now you know how to do this. We can divide the rest of what's there. So if we want to get rid of this 4 kilograms, we can divide both sides by 4 kilograms, divide this side by 4 kilograms. Kilograms cancel out, 4's cancel out. Kilograms cancel out on this side, but then I have 14 divided by 4, and then just meters per second. So I can do that math over here. So I've got, let's see, 14, 4. 4 goes into 14 3 times, it gives me 12. Subtract, getting me 2 left over. Bring down the 0, add a decimal. 4 goes into 25 times. My answer is 3.5. So now I've got V2 equals 3.5 meters per second. And that is my final answer.